Hey everybody, Mr. Kowalczyk here. Today we're going to jump into Unit 8, Lesson 1, which is all about proving triangles congruent. Now this whole unit is going to be all about congruent triangles. Everything we're doing in this unit is trying to prove that we've got two triangles that are exactly the same as one another. Please note, there's a little small typo here. Change these standards to 12.1 and 12.2 in your lesson first off. Now, secondly, this QR code up here, I want to point that out. Each of the lessons here, except for one of them, are going to have QR codes up at the top. This is for extra help. If you are doing this lesson and you feel like you need some extra help, go ahead and point your camera on your device at this particular QR code, and it will get you to a YouTube video that's going to give you extra help beyond this one, in addition to this one, okay? All right, now let's go ahead and jump in here. First thing we're going to do, we're going to show two triangles are congruent using side, 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 angle, angle, and angle, angle, side. Now, these are shortcuts that we're going to need in order to help us prove triangles congruent in a more efficient manner. The opener we're not going to do in the video, may do that in class, might not, okay? Now let's jump down here to the vocabulary section. Congruent triangles are two or more triangles that are exactly the same. What that means is that they have three pair of congruent sides and three pair of congruent angles. Now for our diagram, we're going to draw two triangles that are going to look the same as each other. I'm going to label this one ABC and this one X, Y, Z. So we have three pair of congruent sides, which means that this side here is going to be congruent to this side here. AC is congruent to XZ, AB is congruent to XY, and CB is congruent to ZY. So those are our three pair of congruent sides. And we also have three pair of congruent angles. So angle A is congruent to angle X, angle C is congruent to angle Z, and angle B is congruent to angle Y. Three pair of congruent angles, three pair of congruent sides. Now a congruency statement, okay? A congruency statement is going to be a statement that shows which sides and angles are congruent to each other. And what does that look like? Well, the sides and angles need to match up. They need to be in the same order. So here, if I look, I have A has one arc on the angle, B has three, and C has two. So I need to go in the same order in this triangle here. So if I were to say triangle A, B, C, that's going to be congruent to one arc to three arcs to two arcs, X to Y to Z. It's got to be in that same order. The order is very important in a congruency statement. Okay. Now I don't have to make it alphabetical. I could also say triangle, let's go one arc to two arcs to three arcs. A, C, B is congruent to, I have to do the same thing over here, X, Z, Y. Triangle X, Z, Y. But I have to go in the same order in both of my triangles. Okay. Now corresponding parts. Corresponding, another way to think about corresponding is matching. Okay, so corresponding parts are parts of triangles that are congruent to each other. I'm sorry, I left out a congruent here. There's parts of congruent triangles that are congruent to each other. So for example, if we look at our diagram up here, well, what's congruent to AC in our triangle over here? XZ. So then what I could say is AC, segment AC is congruent to segment XZ. And I could go all the way around and say that. So CB, segment CB is congruent to segment ZY. Segment AB is congruent to segment XY. Those are my sides. And then my angles, I have angle A being congruent. This angle here is congruent to this angle here. It corresponds to angle X. Angle C is congruent to or corresponds to angle Z. And angle B is congruent to or corresponds to angle Y. All right, so we have congruent triangles, our congruency statement, and the corresponding parts. Let's move on to our next page. Okay. Now, the goal for today is to learn how to prove triangles congruent to each other. And instead, what we don't want to do is we don't want to have to prove 6 different things. We don't want to have to prove that all 3 angles and all 3 sides are congruent, because that can be tiresome and tedious. So what I'm going to give you right now are 3 shortcuts that allow us to say, oh, these 2 triangles are congruent without worrying about other stuff. So let's go ahead and jump into some of those here. We've got 4 of those today that we're going to work with, these 4 right here. So side, side, side says that if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. So an example. Let's say we have triangle D, E, F, and we have triangle G, H, B. And we know, or we see in our diagram, that we can say that this side is congruent to this side, that DE is congruent to GH, and that FE is congruent to BH. Side, side, side. So that shows us that side, side, side is congruent. Therefore, our congruency statement for these would be, and remember, order matters, triangle DEF, DEF is congruent to triangle G to H to B. Side, side, side. All 3 sides are congruent in both triangles. Now, side, angle, side. Use a different color here. If 2 sides and the included, I'll explain this in just a sec, included angle are congruent in 2 triangles, then the triangles are congruent. Let me explain what I mean by 2 sides and the included angle. So here we've got our triangles. And notice I'm drawing different types of triangles for each of these diagrams. All right, so now we have W, Q, P, and A, R, C. Now, 2 sides in the included angle. Included means that the angle in question has to be between the 2 congruent sides. So let's say we have side WP congruent to side AC, and we have side PQ congruent to side CR. The included angle would have to be the one between those two. So that would need to be angle P being congruent to angle C. So this, as we move around the triangle, we start with one side that's congruent, then we have the angle, and then we have another side. So side, angle, side. The angle is sandwiched between the two sides, and that's going to tell us that the two triangles are congruent to each other. I'm going to write my congruency statement over here so I have a little bit more room. I have to squeeze it in. I've got triangle. I'm going to start up here at W, go across the side that has one tick mark to the angle, and then down the side that has two tick marks to the other one. So WPQ is congruent to triangle. Start here and go across the side that has one tick mark to the angle, and then across to the two tick mark side, ACR. ACR. Now, this isn't the only congruency statement, but it's one that I'm going to write right now. Okay? Side, angle, side. Now, let's do angle, side, angle, which is very similar. It's just reversed from side, angle, side. Okay, so now we have basically the same thing. If, but we change the angles inside. Two angles and the included side are congruent in two triangles, then the triangles are congruent. All right, so let's take a look here. Let's do some obtuse triangles. All right, we've got P, Q, S, and T, U, V. So now we have angle P being congruent to angle T, and we have angle S being congruent to angle V. These are two angles. The included side is the one that's in between them. So this side, VT, would have to be congruent to SP. Angle, and then the next side, and then the next angle. We can't jump angle, side, angle. We have to do the included side, angle, side, angle. So that tells us that triangle PSQ is congruent to triangle TVU. And our last one, angle, angle, side. Angle, angle, side. So this is one, just pay attention to this last one. We're almost done taking notes for the day. Angle, angle, side. So if two consecutive angles, nope, sorry, I misplaced the word consecutive. If two angles and a consecutive side, sorry about that, are congruent in two triangles, then you guessed it, the triangles are congruent. So what does that look like? Let's do an isosceles triangle here, or something that looks like an isosceles triangle. So here we have R, S, T, and X, Y, Z. So angle, angle, side. Two angles and a consecutive side. So now I'm going to tell you that angle R is congruent to angle X, and angle S is congruent to angle Z. So they might not be isosceles. So we have one angle, another angle, and then the very next side right here. This one, side TS. Angle, angle, and the next side right over here, if we're going around the triangle. These are congruent to each other. So we have angle, angle, and then the next side. Angle, angle, and then the next side. That tells us that triangle. I'm going to start up here at T and then go down my side to the 2 arc and over to the 1 arc. So I'm just following, using landmarks to follow the same path. T, S, R, is congruent to triangle YZX. And again, you can have different congruency statements for these. That's the one that I chose right now. Okay. These four, side, 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 angle, and angle, side, will prove triangles congruent if you follow those rules. Now, there are two that will never prove triangles congruent. The first one is angle, side, side, also known as AS. And a good way to remember this is there's no AS in math. So it will not work. If you find angle, side, side, here notice you have an angle, a side, and then the next side. An angle, a side, and then the next side. Well, you can look at these two triangles here and see that even though the angle, the side, and then the side are congruent to each other, we could take side BC here and then triangle in this side. You can, instead of having it be right here, you can hinge it open so that it opens up to here. And then side DF is way longer than side AC. So without any more proof, angle, side, side is not going to work. Okay, so it doesn't work at all. Angle, angle, angle doesn't work because they can be dilations of each other. See how the three angles are congruent? The shape is the same, but the size is different for this one. Okay, so shape is same. Size could be different. That's why it doesn't work out. So it could be a dilation. And dilations are not congruent because they're not the same size. They have to be exactly the same size. Okay. So in this one, we said the shape could be different. All right. Let's do like one or two practice problems and then we're done with the video for the day. Okay, here we are. State if the two triangles are congruent. If they are, state how you know, and write a congruency statement. All right, now the first thing we need to look at is these triangles. First of all, we don't know if they're congruent right away. We've got to deduce some stuff from what we can determine from the diagram. Now in number one, what we can see is that we've got triangle ABC, and we also have triangle ADC. I see that this angle here is congruent to this angle here. And then I also see, so I'm going to say that angle DAC is congruent to angle BCA. So that's one thing. So I have an angle. And I also know that AB, side AB, is congruent to side DC. Now here's the other thing that I want you to notice. AC is shared in both triangles. So this side AC is the same for this triangle as it is for this triangle. So I can actually write down side AC is congruent to side AC. It's almost like I need to write it down for triangle 1 and for triangle 2. It's a way to state what I have. All right, now let's look at our shortcut since we have three things that match up with each other. So for triangle 1, I've got my angle here, and then I have my side here that's congruent, and then I have my second side right here that's congruent. Let's see if that matches up in triangle 2. Well, I've got my angle here, my side here that matches up, and then I also have my side here that matches up. So what is that? What shortcut does that point us towards? That points us towards angle, and then side, and then side. And what did we say about AS? We said there's no AS in math, so triangle ABC is not congruent. Sorry, I'm going to back up. We're not saying not congruent. Let me pause for a second. Because there's no AS in math, we cannot determine whether or not they're congruent without more information. They might be, but we can't determine it. So we're going to write cannot be determined for that one. That's going to be our answer because there's no S in math. It tells us that we don't know if they're congruent or not. All right, let's jump into number 2. Number 2, now let's go ahead and look at what we have to be congruent. We've got this angle here and this angle over here. We have these 2 triangles. So my first thing I'm going to do is I'm going to say angle HEG is congruent to angle FGE. And then I also know that my 2 arcs are congruent to my 2 arcs over here. Angle HGE is congruent to angle FEG. The 2 arcs are congruent to each other. Now, just like we talked about in the previous one, side EG is shared between the 2 triangles. So then we have to say side EG is congruent to side EG. We call that a shared side, right? So now let's go ahead. I've got my angle here. My side here. And my angle here. And then in triangle 2, that's going to point us towards angle, side, angle. So 1 side, 2 congruency tick marks. 1, my side is congruent, and I have 2 congruency tick marks. So that tells me that triangle, and I have to do it in order here. I'm going to go from my 1 arc across the side to my 2 arcs. So that's going to give me E, G down to H is congruent to, I start at my 1 arc, which is over here on this side for this triangle, the orange one, G, E, F. Triangle G, E, F, and I have to say Y by angle, side, angle. That's my shortcut. Okay, that's all for today. Thank you for hanging in there. I know that was a little bit longer video, but we had a lot of information to cover in this first lesson. The rest of the videos won't be as long as that one. All right, y'all. We will see you in class, and we'll work on the rest of these practice problems after doing a short review. Good work. Take care.